and Q2 prime being on L, and you'd have Q2 and Q2 prime being on L2, and that's impossible because L and L2 are different. Okay. What else do I need to show?
There's a line between Q1 prime and Q2 prime.
Do I want to do that yet? Yeah, there is.
Yes, and then that line.
Wait, I want to do two more quick things though before I get to that. I want to show that this point is not that point, and that point is not that point. Why is that true?
Because same thing, then you have like.
I think it's actually more straightforward, right?
Yeah, because
I have.
Then L is already intersecting those two, and then if that was the other point on L1, then it's the same problem as if L was intersecting. It's like you have two. Yeah.
Yep. So if Q1 prime was on L is if Q since Q1 prime is not on L. If Q1 prime is not on L and Q2 is on L, that tells me that Q1 prime is not equal to Q2. And over here I have that Q2, since Q2 prime is not on L and Q1 is on L, that means that Q2 prime is not Q1. Okay.
Can we establish that Q1 prime is not Q2 prime?
Q1 prime is not, I don't think I have to. No, I think I do have to.
Yeah.
Okay, let's do that really quick.
Wait, what?
Wait,
Wait, what?
And like you previously found, actually, I'm not sure. It's Q1 and Q2 that we just reversed down to. Or we need to do
Okay, so now like they're all different, right?
Wait, I think they're all different. I have one more thing over here.
T1 prime and Q2 prime.
Oh yeah, yeah, Q1 prime and Q2 prime.
I don't like the order there.
Oh no, that doesn't matter.
Q1, like, have I actually shown all these things? Q1 prime. Yeah, so I should probably just like write this here. So Q1 prime is not on L. Q2 prime is not on L. Okay, wait. So what? Okay, so good. What the hell are we doing again? We need to show that
there's a line.
No, you can't prove that. We haven't proved that Q1 prime doesn't equal to Q2 prime. So we haven't proved that.
Okay, I think I can do that. I think I can do that right now, right?
Right?
Could Q1 prime be on L2?
Yeah, like that's.
I think
Yeah.
no, right?
Why not?
Q1
They don't
prime
intersect
cannot be on L2 because if it were,
Why is that?
because then we would have.
That could just be the point they intersect. I don't think it matters.
Like, what are we even trying to do?
Yeah, no, watch.
Wait,
Because
this is.
if they are the same thing, then there's just a point there. There's a line.
No, the L would intersect with L2.
I don't think that's fine.
Wait, I need to add a line through Q1 prime and Q2 prime, which is what they've been telling me to do for the last 5 minutes. I wanted to show that they were distinct first.
What?
We haven't shown it yet.
Yeah, but I feel like we're pretty much there, right?
What?
And not.
Why do they have to put this?
What'd you say, Ethan?
With just those three lines, it's okay for Q1 prime to equal Q2.
Yeah, that's what I was saying. I
It's
don't think
only
they
if you add in the next line.
Oh yeah, there's now three.
Yeah, that's.
Then we wouldn't be able to construct the line, which is what we need to prove.
Yeah.
There is a point on both L1 and L2.
Yeah, that's true.
Yeah, so.
Okay,
Right now
so
it's
I
not a
think,
problem.
okay, so we're gonna make a line now through L1 and L2. Or sorry, through Q1 prime and Q2 prime. Let's call it L3.
We already have.
Shit. Let's call it L prime.
Wait, you
Yeah.
have
No, I think it's okay. I think what I'm gonna do, believe it or not, I think I'm gonna leave it as, I think it doesn't matter whether these 2 points are the same or not.
Yeah.
How can you
Okay.
construct the line?
Well, there just must be a line through any given point, there must be a line.
Yeah,
So if they're distinct points, then
Another-
there's a line through them.
Wait,
How do you
another
know
thing-
that it's not L1 and L2, which is already constructed?
Okay, wait, but even, wait,
Um,
if it was 1 point, then like, there has to be 3 lines through.
True.
Because of that, because of like LPP3, and then there's another line through it, and L has to intersect that other line, and that's how it would finish, if they are the same. But if they're not, you don't even run into that, like, that's like,
Wait, if they are the same, it's contradiction?
if they are the same, there has to be another line through the point, because there are 3 lines through every point. By that, like,
Yeah, that's
right?
true.
Yeah, and so it
Because that would be
doesn't,
a
it doesn't matter, like, if they're the same.
Wait, I think I can show that they're different. Can I?
No,
Why not?
Because-
I just kind of just zoned you out for a second, but can I just do this if they're the same?
if they're the
You
same,
could draw
then
a
all it
picture where
is
they're
is
the
where
same
it's where
now.
L1
So
and
that you
L2
can
intersect,
figure
and that's not like, we have no way of
It's not
like
like-
saying that's not necessarily the case, but it doesn't matter if they're the same or not.
Okay, so let's just finish this off. Let L prime be the line through Q1 prime and Q2 prime. So Q1 prime is on L prime, and Q2 prime is also on L prime. Okay, and now this line must intersect L somewhere.
Yeah, necessarily, and it can't be a Q1 or a Q2 because,
It can't be a Q1 or Q2
yeah,
because
it can't be at those points because if it was, then L prime would intersect like L1 or L2 at 2 different points. It's like the same contradiction.
Right.
Yeah,
No, but that's just saying that,
if they,
that's just saying L1 is L1.
no, it's
Like,
like,
there's no reason that
but,
L.
yeah, no, there is, because,
Why
if
can't L prime be?
Wait a
L1?
second, then that proves, since there has to be a third point, that
well, it's
proves
like
that L
a
has 3
distinct
points
point,
on it.
like,
How do you know?
And that's
because,
the same.
well, first of all, Q2, if.
so right.
Q1
So
has
so
a
the goal was to show.
And then if they're the same, then.
If they're the same, you can
So
still.
wait. So maybe this
I don't know,
maybe
it's
this
like-
is the
It's
goal.
still 3 on
The
L.
goal is to show that there are 3 points on line L.
Okay, so if Q1 and Q1 prime and Q2 prime are distinct, then we've shown there are 3 points on L. But if they're not, but if they're the same,
Wait,
then may have been a problem.
what, if they're the same,
Wait, if
then,
they're the same, then those two, Q1 and Q2 have to share.
can't you just like make some statement about like
No,
L
but-
prime is distinct, like, from the rest of
Yeah,
them?
because we don't
Changes.
know
One
that
and
every
two.
point has 3 points, but it's the opposite of this. So we're like,
But
assuming-
either way, either way,
Q has to be
like a triangle.
No.
oh yeah, no, it's, each point has to have 3 distinct lines.
We don't know that.
Yeah, we kinda do.
They have to be- Yeah, they have to be distinct.
We kind of do know that because because every 2 points, there's a line through them,
Q1
and there have to be the 4 points.
Yeah, wait, no, but if each line has to have 3, like, if each point has to have.
We don't know that.
Through it, why do we, no, we do, that's like.
No, because then we're just making a dual argument.
No, we do know that because if there are, we know there are 4 points. Every 2 points, there's a line between them. There have to be 4 distinct points, so there have to be 4 distinct lines.
Well, yeah, no, Mr. Rose, do we
Yeah.
need to use the converse to prove this?
No, I think
But the last time we needed FPP3 to prove FPP3 prime, so I don't know if it's like a similar situation.
Yeah.
Q1 and Q2.
Oh yeah, right, that is kind of the converse. Every line has, every point is 3 distinct. But you can prove that, that's the trick.
I know.
Hold on. I think we're pretty close to being done. I didn't. This is harder than I thought. I underestimated you again. I'm at 8.3. Yeah. So let's just skipping over possibly some confusion. Can we argue? That Q is different from Q1 and Q2? I think we can.
Yes.
If they're distinct.
If the points, if Q1 prime and Q2 prime are distinct, then it's easy because then, if it, you just do it by contradiction, like if it weren't, then,
So wait,
L prime would hit that point at
So wait, is it just the case
a
that?
distinct line at 2 different points. If they're the same though, that's like a little bit harder to make.
I think we have to use the fact that there exist 4 points if Q1 prime equals Q2 prime.
Oh, yeah, that's-
Maybe you,
so
wait,
that-
I have an idea. I think if instead of introducing Q1 prime and Q2 prime first, you introduce L prime first.
No, wait, hold on. Ah! Okay, wait. why can, let's just kind of finish it and maybe we'll just fix this up. So wait, why, I'm so sad. So wait, why must these, why is Q different from Q1 and Q2?
I can explain it.
I think,
It's
what?
because if Q were the same as Q1 or Q2, and it runs through Q1 prime and Q2 prime, and those points are distinct, then L1 and L prime would intersect at two different points, in spite of the fact that they are distinct, because L prime contains Q2 prime, which is not on L1.
Also, Gossett never bothers to address whether.
Yeah, he skipped a lot of details.
He
To the
just
point where I
says-
thought his proof was just wrong, but then I fleshed it out and I found that it wasn't wrong, it was just heavily skipped. But now I'm suddenly not totally seeing it, and I'm kind of being put on the spot here. But I think I think the argument works, right? I want to show, so why is Q1 not equal to Q2? Or why is Q not equal to Q1? If Q equals Q1, then
L prime and L1 intersected 2 points,
then
even though they're distinct.
L prime and L1 intersect at 2 distinct points. Why is L1 not equal to L prime? Maybe that's worth mentioning first.
Because L prime contains Q2 prime, which
Yeah.
and
Wait,
So
why-
so here's what we know. We know
Isn't that
that
what our argument was?
what?
If they're not distinct, then that's okay.
I think it's okay, yeah.
Yes, yeah,
So Q2 prime is not on L, that's a fact, but Q2 prime is on L prime, so that's enough to conclude that,
not on L1 you mean.
sorry,
The first